Hello, everyone, and welcome to another behind the scenes episode. And today we're talking about how to get into coding. This is probably one of the most frequently asked questions because I'm usually speaking with, cybersecurity professionals who want to learn a bit more about AI and therefore want to learn how to code or how to code better. Or I'm speaking to people who are looking at becoming data scientists and they're sort of starting out on that journey and wanting to learn how best to code. If you can hear the washing machine in the background, don't mind me, this is the benefit of working from home. So I thought I would make this episode about how to learn to code because even though I code every day now, and you could say that I code for a living, it wasn't until I was in my first proper professional career job when I was in my 20s that I actually started coding properly for the first time. At university, I studied physics and bioanthropology, and you would think that for the physics portion of my degree, I would need to code. And I did a little bit in programs like MATLAB or Mathematica. People who come from math backgrounds will know that those two are programs and languages that are for sort of mathematical modeling, but definitely not anything like data science or software programming. So it was really quite a shock and it was difficult to learn how to code good. And I feel like coding is also the kind of skill that you never think you're good enough at because you could always be better. You could always be more efficient in how you write your code, the way that your code runs. Coding is a big field for imposter syndrome, but I'm now at the point where I think my coding is good enough. Some people might say is great, other people might say is crap, but that's not the point here. So this is the notebook I showed you from the last behind the scenes episode in how to build an AI and how to get into data science. And I'm going to sort of talk you through what's important to understand about the coding process if you're actually looking to learn how to code. So if you haven't already seen this episode, I recommend you go and do that. I'm going to point up and maybe I'll be able to figure out how to put an image in there. Or my editor can. Thanks, Cynthia. And we're going to sort of have a look through, how you can get to the point that you can build up a notebook like this. I also want to say here that obviously all people who code, it's very much about standing on the shoulders of giants. So the point of this particular video is not to leave you proficient at programming, and it's also not even to tell you that you need to be proficient at programming. I hope you get out of this episode that if you want to learn to code, you can, but also maybe you don't need to learn to code, and therefore you shouldn't spend a lot of time on it. If it's something you feel like you should learn because people talk about code, if it's not really going to benefit you or your role or your business or the projects you're working on, then look, you don't need to do it. So let's start off with the history of programming. And some of you will probably have, known that computers originated from these kinds of machines that required punch cards. So this is a punch card. And I remember when I was first told that computers relied on punch cards, I just couldn't quite comprehend what that meant. But if we think about a modern computer being about electrical circuits that either connect together to send electrical signals through a circuit, or they don't connect and therefore don't send an electrical signal through a certain portion of the circuit, this is what we mean by zeros and ones. So at the end of the day, a computer is built up of circuits. And a 1 value means that the circuit is connected and there's an electrical signal being passed through from one place to another to help, inform decisions or logic gates and things like that. Or it's a 0, which means that there is no connection between that particular circuit and therefore no information being passed through. So this is exactly what these punch cards represented, but in physical form. So in a punch card, you have all these different sort of positions that correspond to circuits in your actual machine. I'm trying to get a good picture here. So this is a good one. So this is an example of a slightly later version where they're now using actual sort of wires that they connect together. But the point is that you have, actual physical components that are there and you either want to send a current between or not. And so what these punch cards essentially allowed was for that circuit to either pass through where there was a hole punched and if there wasn't a hole punched, then the circuit wouldn't be able to pass through. So this is the origin of computing, and you end up with programs run by stacks that are sort of yay big, enormous. And it's often a fun piece of computer history trivia that's pointed out that most of the original computer programmers were women, because back then it was seen as a very tedious, monotonous, low-level kind of job, and those are the kinds of jobs handed to women. But it's a cool kind of history now that computer programming is seen as so important and rich and requiring a lot of intellect to be able to do. So when we think about moving forward in time through computing, you then end up with computers that are essentially run using mechanical and hydraulic components. And then our modern era of computing is one where it's electrical signals. But at the end of the day, it's all about the passage of information and being able to code that. So what that looks like these days is code that looks like this. So this is written in Python. As a data scientist, Python is my language of choice, as it tends to be with most people. But let me play this little visualization of sort of the most popular computer programming languages through the years. So sometimes when I'm in jobs, I've been in teams and there's, older people there, and they'd be like, oh yeah, I used to code in Fortran and COBOL and BASIC and blah, blah, blah. And they were, very proud of it. And I'd be like, okay, especially when I was younger, because I had no idea what they were talking about. But Fortran and COBOL were some of the most important computer programming languages, and they're referred to as fairly low level. Not in that, you didn't need to be quite smart to be able to use them. You can, although it's also a, kind of smart that can be learned. But they're a lot closer to sort of the hardware. That's usually what we refer to by talking about low-level or high-level computer programming languages. If you're closer to the hardware, it means that the kind of language you're using is far more suited to actually controlling hardware components and electrical current. I'm going to show you a little example of some Fortran code, just to show you what it looks like. So you can see that it's not at all like the kind of code that I showed you before, and it does actually refer to like specific parts of memory, whereas that's just not something that I need to worry about. Fortunately, people have, iterated and updated programming languages over time, so that now I don't really need to worry so much about the computer itself, or at least the languages that I'm programming in kind of automate away a lot of those considerations. But this wasn't the case in some of those earlier languages. So let's skip forward to here, 2006. This is when I started using computers properly, when I was at school. And we can see that Java, JavaScript, PHP, and the C family of languages are the most popular. And this is because they are the languages of software and software programming. So software really is just, computer program that will do something in a automated fashion. And so the 2000s was the era of software and of web development. So PHP is a popular web development language. You can see that Python is becoming very popular as we hit the 2010s, and that's because we're moving into the land and era of data science. Growing in popularity, at least software is still really important. And so Python is very quickly taking the lead as we get closer to modern time. Some of you might have heard of some of these other languages down here: Ruby, Swift, C, and now we have Python as number one. So that's why I often do most of my demos in Python. It's usually more useful. This visualization stops in 2019, but I don't think anything has changed. But Python is a really useful language to know because most programs tend to use it these days. I personally highly recommend doing a computer programming course if you're looking to get into programming for the first time. The way that I think about computer programming is that it's just like learning any other kind of language. Like French or Russian or Chinese. It's really important to understand all of the grammar rules and how to use languages, how to craft sentences properly, how to, understand syntax. All those rules are very important, but then it's really in the practice and, practicing speaking it, practicing reading it, that allows you to actually become quite good. So if you do have access to sort of an instructional computer programming course, I recommend that, but also it really depends on your learning style. That's the kind of thing that I flourish doing. I really like the structured format of a lot of courses, but then being able to practice by myself is really important. So I'm sure you will have access to a Python class somehow. There's lots of free online ones. If you're at university, make the most of either like scheduling yourself onto a programming course or audit one. I've audited plenty of classes during my time, and lecturers usually get so excited that someone just wants to learn that, you can sit through many classes for free, which can be really useful. And when you get to the stage of actually practicing your code, this is where it really helps to do sort of projects and things. Another thing that's really important about programming is the idea of thinking computationally. So it's one thing to be able to understand the language rules and how they sort of come together, but it's another thing to understand how to apply that for yourself. And there's a couple of programs that I'd recommend to learn how to think computationally. So regardless of whatever coding language you're using, just being able to use logical statements and things. And so one is Brilliant. I've showed this in the last video, but basically you can, this is in the Thinking in Code course, and it has lots of cool sort of exercises where you can just practice the way that computer programmers think. So putting together lots of different blocks to be able to basically build a program. There we go. Another site that does this is Blockly. And Blockly, I believe, is now taught in schools, which is great. So some of you might have done this before. But they have lots of different games where you can test your computational abilities. So if I check out Bird, for example, on level 1, they basically have these blocks that correspond to different lines of code. I've got heading 45 degrees. I'm going to run this program, and the bird gets the worm, and then it lands at its nest. And then it has some cool bird noises. And then it does actually show you what that code looks like in JavaScript, which is pretty good. You can move up the levels and eventually find yourself building programs like this, which include if and else statements. So let's run that. That was incorrect. So I obviously need to finish that code so that I can get up to the nest. But that's sort of the point. You practice being able to build all these things. And then by the time you get to level 10, it's a very general solution. So instead of specifically helping the bird get to the worm and then the nest, it's sort of so that for any situation that the bird is in, it will be able to find the worm and the nest. I mentioned Kaggle last time. Kaggle can be a really good place to practice your data science coding skills in particular, because there are lots of different competitions you can enter, and they often have solutions already. So these are the existing competitions, but you can look at previous competitions and then follow the notebooks that they have here already. So we can open this one, for example, and see that we have this model notebook ready to go here, as well as sort of access to the data and all that kind of stuff. I'll let you, you can go and open that yourself. But if you're looking to sort of figure out how to actually start coding, there are two places I would recommend that are really just easy to start. The first is Google Colab, which is the environment I'm working in here. And the next is Jupyter Notebook. So they're basically web-based computing platforms, so that you can just very quickly sign up and start coding without having to do too much configuration. I often find that one of the hardest parts of getting started on a project, if I haven't picked it up in a long time or like in a new language, is just getting my environment set up. For example, in this notebook here, I have to import these two packages. I think I import more further down, but sometimes you're importing many different packages and they all have different versions, and it's trivial, doing this kind of thing when you're using someone else's compute, because it's configured correctly, and because I know that Google, providing this service to me, which I also pay for, is updated, it's easy. When I try and import these things into my local environment, I often end up with all kinds of bugs because the different versions are incompatible, they save into weird folders and whatnot. And look, as a data scientist, yes, I can work my way through it, but I'm not a computer programmer. I don't want to have to deal with that. So I'd rather let someone else deal with that. Speaking of bugs, the other important thing to note about the computer programming journey is time spent debugging. All of these diagrams basically show that debugging code or fixing problems in code often takes far more time than the actual coding itself, which might be ridiculous. It might sound ridiculous because, building a long notebook can take a lot of time, and this is a short notebook. But let's try running this, for example. Okay, so I've got a bug here. The great thing about using someone else's environment, particularly one of the more modern platforms like this, and even ones where you use your local environment and you're downloading the software, would do this, but they show you where you're going wrong. So I don't know if you can see this, but we've got a syntax error, incomplete output. It seems to be pointing to here, but we can also see that there's a little sort of squiggly red line that goes all the way through here, and that's because I haven't closed this function bracket. So if I run this, then we've been able to input that data and show it correctly. This is the kind of bug that you wouldn't get once you know the syntax requirements of different languages. So again, the value of going to a computer programming course, knowing that you have to have round bracket, closing brackets and things like that, and the right way to write your code. But it's also the kind of bug that anyone can also do, because you might just do a typo and you forget to close that bracket. And I easily spend most of my time debugging when it comes to code, either because of typos like this, or because I'm just not very familiar with the libraries or the packages that I'm using, or because something weird has gone wrong and I have no idea what the problem is, but eventually through Stack Overflow, ChatGPT, trial and error, I'm able to understand that I've done something wrong for some reason because I haven't understood the requirements of the package, and it's just taken me that time to figure it out. This is also a good time where I should mention ChatGPT, because ChatGPT can have enormous value when you're learning to code. So, for example, you could ask it, I want to learn to code. How should I do that? And it can recommend resources. You can be as specific as you like in your goals. So you can say that you want to learn to code for data science, you want to learn to code for software engineering, all kinds of things. And you can ask it to recommend different courses for you, different free or paid services where you can learn. Another thing that, maybe this is an unpopular opinion, but I'll often ask it to sort of help me write code, and then I can learn through that process as well, specifically by asking it to annotate what I'm doing. So in Python code, write me a program that imports, data from Kaggle, annotate so I understand what you're doing, and explain the process to me afterwards. And even as someone who codes all the time, I'm always finding myself needing to use new libraries and packages that I'm not very familiar with. Also because the field moves so quickly that if I'm using a new model, I just want to quickly understand how to use it. I don't necessarily want to read through all the developer documentation. So using ChatGPT or Gemini, which is now what Google's Bard is called, can actually be really helpful, because not only does it give me the code, which is useful but you shouldn't just rely on alone, but it explains exactly how it works. And then if you get confused, so for example, it's telling us to install the Kaggle API and then obtain Kaggle API credentials. You can be like, what is an API? An API is an application programming interface, which fortunately I did already know before asking it this question. But you can, ask it to explain to you all these different things. So I recommend starting off with a specific programming course based on the code that you want to learn and, the use case that you're learning it for. And then start actually working on projects. And ChatGPT or any other chatbot can be a really useful resource to help you understand different lines of code that you're not familiar with that might not already be well described in the coursework you're doing or in the developer notes of the library or package that you're using, or things like that. So I think that's it. I know this hasn't necessarily been a lot of hands-on coding. I can do that in a future episode. Maybe I'll do a part 2 of how to code and walk you through a kind of easy example. However, there are also lots of other notebooks that I'll be showing you in the behind the scenes video that you can use as those case studies as well. But let me know in the comments if you do want me to go into some of this in more detail, or if you want me to walk you through an easy getting started kind of project, or if you have any other questions about coding in general, or like the best languages to learn or the best kinds of use cases to be learning on these days. I'm really happy to answer all of those questions. So thank you very much for being here. Please like, so that I feel like I'm providing some value and not just sitting here while I wait for my laundry to dry. And subscribe, as that's a really kind free way of helping my channel. And I'll see you in the next episode.